Okay, so in this video or lesson, we're going to briefly introduce to you what is a linear relation. And we're going to have a look at some of the terminology behind linear relations. But just a quick recap. Let's have a look at this. The Cartesian plane. Have you seen this before? Yes. Now, what I want you to think about is this. Is that what comes before Y in the alphabet? X. So what comes first in a coordinate system? X. I want you to always remember that because a lot of you forget that. We have it, generally speaking, an XY, and this is what we call a Cartesian plane, which is named after René Descartes, and I'm going to show you René Descartes. And it says that René Descartes was a French philosopher, mathematician and scientist who spent most of his life in the Dutch Republic. So he was Dutch. He was not French. And he actually came up with this coordinate system. He did a lot of what we call analytical geometry. And it says here that Descartes' influence in mathematics is equally apparent. The Cartesian coordinate system, allowing reference for a point in space. He had done a lot in the field of mathematics. That's where Descartes, so maybe you'll probably think about the word Cartesian. Well, it's simply just this. This is the Cartesian coordinate system. X and Y, a coordinate system. So let's have a look at the coordinates. Just think about, now we can actually consider these as quadrants. This can be considered as quadrant 1 if you like. Starting from here and working our way anti-clockwise. This can be considered quadrant 2. The reason we call this quadrant 1 is because what are X values? X values and Y values in quadrant 1, what can you tell me about them? They're positive. Okay, good. Now, what can you tell me about X values and Y values in... What can you tell me about X values and Y values in the second quadrant? What's negative? Good. So X is negative and Y is positive. Guys at the back, one of you move up here. If I hear from you again. If I hear boo from you again. Do you understand? Zip it. What about in the third quadrant though? What can you tell me about X and Y? In the third quadrant, they are both negative. Absolutely. So X is negative and Y is negative. And of course, in the fourth quadrant, the good old fourth quadrant, well, we know that X is positive and Y is negative. Well, that's not technically correct because what about the good old point in the center? What do we call that? 0, 0. What do we call it? We call it the origin. The origin. Okay, and I'm going to spell it for you. Origin. Original. Origin. Origin. Okay. So far, I hope that you've seen that before, and if you don't understand the Cartesian coordinate system, Phoebe, X comes before Y, so you know then, what's the X coordinate over here? What's the X coordinate over here? What's the X coordinate that I've just circled over here?
I can't see that.
Oh, okay, sorry. Can I zoom in maybe? Oh, there's a bit of lag. Okay, can you see that now? Okay, what's the X coordinate? 4, good, because X comes before Y, well, doesn't it? Okay, X, Y, all right? A lot of students make that silly mistake. All right, now what we're going to do now is we're just going to have a look and actually sketch a graph. Shh. So what is a linear relation? I've been through this before. I went through a situation with you where age and height, there was a relationship between age and height. We're looking at an independent variable, which we might call X, and we might call a dependent variable, which we might call Y. In this case, there's a relationship. Now, there's actually a direct relationship. Now, I'm going to explain this just quickly. As a physicist, and by the way, a lot of you should be doing physics if you're interested in how things work. But what kills you? Voltage or current? In electricity. What kills you? Voltage or current? It's current. Because current is the flow of electrons. Current is like more flow of electrons means it's going to hurt you more. So you could touch a 10,000 volt. You could touch a 10,000 volt wire with a very, very low, and you could still probably survive it. Very low current. All right. Now you can see here what's happening as voltage increases. What is happening to the current? Increases. Now there's actually like a direct relationship, and that's because V is equal to I times the resistance. Now if the resistance is constant, then that means that this is like saying, let's just say Y equals 2x. What would the graph of Y equals 2x look like? What would the graph of Y equals 2x look like? Well, let's go get our graphics calculators out and let's go and have a look, shall we? Yep. Of course we can. The only problem, can someone go to the common room and ask for the Dakin? Yeah, the Dakin remote. Now, I had a big argument with maintenance. There was never one in here, and the reason why is because the only remote that works is the Dakin one.
Okay, I'll try and find one.
Yep. I'm not. It's on YouTube. I don't want to talk about it. All right. All right. No. I'm showing you. You don't need to get your calculators right now. Now, if I go to shh. Yes. That's right. Exactly. Calculate. Now, look. We go to the home screen and we go to graph. Now, I don't want this scratch pad business though. I want to go to new document and I want to add graph. Now, shh. Let's have a look. Now this thing says f1 of x. That's what that's saying is it's a function of x. I want you to treat that as the dependent variable or the y-axis, because we have an equation of y in terms of x generally. Okay? So, what does the graph of y equals 2x look like? Well, we press enter. You can see there's a graph. What can you tell me about this graph? And I'm still recording. Alberto, what can you tell me about this graph? There's something that's quite... Okay, so it's got to be 310. So,
they've written on it. Yeah.
Okay, and you know why? Because they've turned it up to 25 degrees. Okay, so what can you tell me about that graph?
Straight line.
It's a straight line. Shh. Pete, can you tell me something? Shh.
Yeah, there's no y-intercept.
There's no, well, there is a y-intercept. The y-intercept is 0. Absolutely. All right, so let's have a look at this. Shh. Now, I'm going to pause this video right now just so we can just have a little... So what we've just discussed is that the one thing about the graph of y equals 2x is that it goes through the origin and the y-intercept is 0 and it is a straight line. Okay? It is a straight line, and as it turns out, it has a gradient of 2, but we're going to get to that. Okay. Now, as we discussed, now let's think about it. This is 2x. What happens if I said 2x plus 1? What's going to happen to the y-intercept? It's going to go up 1. So let's do this. Now I'm going to show you, and those people with graphics calculators, you should be doing this. Press tab button. Press the tab button. Because what happens there is it comes of f of 2 of x. Now the tab button, f of 2 of x, means what? It means that it's another graph, and it's going to sketch it in line. Let's do it. Now, can someone tell me, are the two lines going to have the same gradient? Are they going to have the same slope? Yes. Let's have a look. Okay. What do you notice about this graph? It's the same slope, yeah? It's just that one slope is moved over one. All right. What about 2x? Can someone tell me what's going to be the y-intercept of 2x plus... Ooh, I'm going to hit tab. and go, what can someone tell me, what is 2x plus 8, what's going to be the y-intercept?
8.
Oh my freaking God. There you go. Now, I'm going to do something really bizarre here because I'm trying to teach you how to use a calculator. I'm going to go to menu and I'm going to go to Windows Zoom and I'm going to go to, you know what, we're going to go zoom out and we're just going to, no, you know what, we're going to zoom out and we're going to do it again. We're going to do it again. Or maybe, yeah. There she goes. Maybe I'm going to zoom in just once more though. All right. Now, what we're going to do now is we're going to go tab and we're going to put in a fourth graph. This time, I'm going to go 4x plus 0. Now, what are you going to tell me about the graph of 4x? Where is it going to go through? What's going to be the y-intercept? The origin, which is 0. Good. Is this graph going to be steeper or less steep than the one before? It's going to be steep because every time we go across one x value, how many times does y go up? So every time it goes across one, think about it. Let's pick a point. When x equals 1, y equals 4 times 1. Y equals 4. Okay, so what about when x equals 2? What does y equal? 8. Good. Now, let's have a look. Now I could get rid of some of these graphs if I like. I can get rid of that and I can go, I'm not sure how I delete it. I think I go delete. Oh, I can delete. Yeah, but I don't even have my thing on. Okay. Now, you can see there that we've got a graph of y equals 2x and y equals 4x. Now, let's have a look. What is the coefficient of x in this case? In this case here. What's the coefficient of x? 4. 4. Now, let's work out what the coefficient... Let's do it. I'm going to pause this. Shh. Just quickly, the coefficient in mathematics, a coefficient is a multiplicative factor. It is that thing which is in front of, in this case, now we can have other expressions. Now we've got an expression which is a linear expression. And if I was to get this over here, what is the coefficient of x in this case? The coefficient of x is 4. Okay? Now, we have what's called a coefficient and we have what's called a constant. So if I go back to my linear equations thing and we go down here, what is the coefficient? Now, this is a bit of a trick question. Shh. What is the coefficient of x? Or, well, it's tricky. It's sort of like, in actual fact, this graph here is not your typical sort of graph. Now, using Cartesian coordinates, we're not actually... Let's have a look at this one. What is the coefficient of this one, of x? It's 2. What's the constant? -3. Okay. What is the coefficient of x squared? 1. What's the constant? Good. In this case, what's the constant of x to the power of -1? Would be, because that's, remember that when we did our indices, isn't 4 over x the same as 4x to the power of -1? So what's the constant of x to the power of -1? 4. And what's the constant? 1. So the coefficient was 4, the constant was 1. All right, so now what we're going to do is I'm going to sort of give this a little bit of a pause here. And what we're going to do is, using your Cartesian coordinate system, you are going to get the x value and you're then going to plug that into the equation using your calculator to get the y value. And I'd like you to sketch a Cartesian coordinate system. I'm going to pause the video now. I'm going to sketch a Cartesian coordinate system which goes 10 across to the right, 10 across to the left, and we're going to go sort of say 7 up and 7 down. All right? I'd like you to sketch these 3 graphs, y in terms of x, on your Cartesian coordinate system, and then I will go through that before we finish our class. Video now. Now, first of all, this first one was, I'm not sure why we would pick this when we're talking about Cartesian coordinates. I'm not going to go through this one, but I will go through, in particular, the linear equation. What we're talking about is we've got at when x is equal to -1, then y is going to depend on x. So 2 times -1. Now 2 times -1 is equal to -2. And then if I subtract -3 away, we've got -2 minus 3 is going to be -5. Is that what you got? Now when x equals 0, what does... What? Oh. Yes, I am. Yeah.
You lost $2,609.
Thank you. That's fantastic. All right. Now, what about when x equals 0? What's the y-intercept? If I get rid of this, what's the y-intercept? Isn't the y-intercept a constant? Oh. No. I know what I've done wrong. I've done this wrong. Now can you see it?
Yes.
Okay. My bad. That really didn't make for good YouTubing. All right. Now, what's the constant? What's the constant of this expression? -3. So guess where the y-intercept is? -3. Now, when x equals 0, y equals -3. When x equals 1, 2 times 1 is 1. No, it's not. It's 2. Minus 3. I've been on too long a holiday. Minus 3 is -1, isn't it? So now negative. Let's have a look at this though. Like, what does this 2x? What does this mean, ladies and gentlemen? It means that for every time I go across 1. I go up 2. That's the amazing thing. Okay? So when 1, that's -1. So, given the fact that this equation has a gradient of 2, can someone tell me without doing this, 2 times 2, well 2 times 2 is 4. 4 minus 3 is 1. So I go across 1, I go up 2. And is that my equation there? So suddenly, when I sketch the line, that's it. Now, the whole idea is this line, if I was to sketch this line properly, if I was to pick this point and this point, we can actually find that if I was to go from 4 to 6, given that it goes from 4, if I've got the 4 and I go to 6, how much is it going to go up? If every time I go across 1, it goes up 2. If I go from 4 to 6, how much is it going to go up? Well, it's going to go, this distance here is going to be 4, isn't it? Okay, now I'm going to stop you there. Have a go at 4A for homework, and I'll see you later.